So we have a bunch of numbers listed up here, and my goal in this video is to see if we can classify them into different types of number categories. And let me draw the categories. So this circle over here, this represents all of the numbers that can be represented as the fraction of two integers, and of course the denominator can't be equal to 0 because we don't know what it means to put a 0 in the denominator. So let's call these, or the standard way of calling these things that can be represented as a fraction of two integers, we call these rational numbers. Rational numbers. And if something cannot be represented as a fraction of two integers, we call irrational numbers. Irrational numbers. Irrational numbers. And the size of these circles don't show how large these sets are. There's actually an infinite number of rational and an infinite number of irrational numbers. So these are the irrational numbers. Irrational. So these cannot be represented as a fraction of two integers. And then within rational numbers, you have integers themselves. So I'll do that let me do that in this blue color. Integers. So integers are numbers that don't have to be represented as a fraction or a decimal. So these are integers right over here. Integers. And then a subset of integers are whole numbers. So if you essentially say the non-negative integers, you're then talking about whole numbers. So let me do that subset right over here. So these are going to be the whole numbers. So whole numbers. Whole numbers right over here. And actually, let me just label it all. These are rational. Let me do it in that same color. Rational numbers. And of course, irrational numbers. Irrational numbers. Irrational numbers. And an integer, well, if I could say literally, that is an integer. Let's think about the integers, but I wouldn't say let's just think about the rational. I would say let's think about the rational numbers. All right, now that we have these categories in place, let's categorize them. And like always, pause the video. See if you can figure out what category these numbers fall into. Where would you put them on this diagram? So let's start off with 3. This is positive 3. It can be definitely represented as a fraction. You could represent it as 3 over 1. But it doesn't have to be represented as a fraction. It literally could be just a 3 right over there. But it's also non-negative. So 3 is a whole number. So 3, and maybe I'll do it in the color of the category. So 3 is a whole number. So it's a member of that set. But if you're a whole number, you're also an integer, and you're also a rational number. So 3 is a whole number, it's an integer, and it's a rational number. Now let's think about negative 5. Now negative 5, once again, it can be represented as a fraction, but it doesn't have to be. But it is negative, so it's not going to be a whole number. So negative 5 is going to sit right over here. It's an integer, and if you're an integer, you're definitely going to be a rational number, but it's not a whole number because it is negative. Now we have 0.25. Well, this for sure can be represented as a fraction. This is 25 hundredths right over here. So we can represent that as a fraction of two integers, I should say. It's 25 hundredths. But there's no way to represent this except using a fraction of two integers. So 0.25 is a rational number, but it's not an integer and not a whole number. Now, what about 22 over 7? Well, here it's clearly represented already as a fraction of two integers, but I don't think I can represent this any other except as a fraction of two integers. I can't somehow make this without using a fraction or some type of decimal that might repeat. So this right over here, this would also be a rational number, but it's not an integer, not a whole number. Now this over here, 0.2713, and then the 13 repeats. This is the same thing, 0.27131313. That's what that line up there represents. Now, you might not realize it yet, but any number that repeats eventually, and this one does repeat eventually, you have the 0.13, or you have the 0.27131313, any number like this can be represented as a fraction. For example, and I'm not going to do it here just for the sake of time, but for example, 0.3 repeating, that's the same thing as 1/3. And later on, we're going to see techniques of how do you convert this to a fraction of two integers. But for our sake, we just know that this can be represented as a fraction of two integers, just the way that 0.3 repeating can be. And so we would put this under rational numbers, 0.2713 repeating. But you have to represent it as either as a decimal or a fraction of integers. If you didn't have to, then it could have been an integer, but we'll throw it up there in rational numbers. Now the square root of 10. Square root of 10. This is interesting. So any square root of a non-perfect square is going to be irrational. So this is going to be irrational. I'm not proving it to you here, but you cannot represent this as the ratio of two integers or a fraction with two integers, with an integer in the numerator and an integer in the denominator. This will be, if you were to represent it as a decimal, it will not repeat. It'll just keep being new digits. It will not repeat over time. So this right over here is an irrational number. It's not rational. It cannot be represented as the ratio of two integers. All right, 14/7. This is the ratio of two integers, so this for sure is rational. But if you think about it, 14/7, that's another way of saying 14/7 is the same thing as 2. These two things are equivalent. So 14/7 is the same thing as 2. So this is actually a whole number. It doesn't look like a whole number, but remember, a whole number is a non-negative number that doesn't need to be represented as the ratio of two integers. And this one, even though we did represent it as the ratio of two integers, it doesn't need to be represented as the ratio of two integers. You could represent this as just 2. So that's going to be a whole number. 14/7, which is the same thing as 2, that is a whole number. Now 2 pi. Now pi is an irrational number. So if we just take a multiple of pi, if we just take an integer multiple of pi like that, this is also going to be an irrational number. If you looked at its decimal representation, it will never repeat. So that's 2 pi right over there. Now what about, let me do that same, since I've been relatively consistent with the colors. So this is 2 pi right over there. Now what about the negative square root of 25? Well, 25 is a perfect square. Square root of that's just going to be 5. So this thing is going to be equivalent to -5. So this is just another representation of this right over here. So it is an integer. It's not a whole number because it's negative, but it's an integer. Negative square root of 25. These two things are actually the same number, just different ways of representing them. And then you have, let's see, you have the square root of 9 over 7. Well, what's the principal root of 9? This thing is going to be the same thing. This thing is the same. Let me do this in a different color. This is the same thing as square root of 9 is 3. This is the principal root of 9, so it's 3/7. So this is a ratio of two integers. This is a rational number. Square root of 9/7 is the same thing as 3/7. Now let me just give you one more just for the road. What about pi over pi? What is that going to be? Well, pi divided by pi is going to be equal to 1. So this is actually a whole number. So I could write pi over pi right over there. That's just a very fancy way of saying 1.